So anyways, we already in chapter 6, we were solving equations, and I think that was my goal to introduce you with working out some of the exercises and finding the unknowns and clearing denominators. The problems get rather tedious, and I think that's enough with all that stuff, so I can just wrap up here and move to the next chapter, the last chapter that we need for our class. This will be chapter 7. So there are lots of sections that I'm leaving over, and I already told you the reason why. This is a textbook for 5-unit class. Our class is only 3 units. That's why we're not even supposed to look at like half of this textbook, and that's why I'm being selective here. So we're going to look at the last chapter that we need here, and that's chapter number 7, that deals with radicals or square roots and cube roots and various other roots that they have here for us. And I'm sure you already experienced dealing with roots like square root of 121 that happens to be 11. And the reason the square root of 121 is equal to 11 is because 11 times 11, or 11 squared, is equal to 121. So that's like a backwards procedure that we think of when deal with those roots. So they have various little examples here that talking about square root of number 1, which is just the same number 1, because again, when you square number 1, it's 1. You say, what does square mean? Well, it's multiplying this number 1 with itself. That's what we say, square. So you multiply it 2 times with itself. I hope that you already saw this squares before, because we worked a lot with them, and then the backwards procedure square root. So that's what I would like to start talking about today. And as usual, I'm gonna use some of the practice at the end of the section for the examples. So let me try exercise number 38 here that says a square root extracted from 144. And when we find it, it's going to be 12. So the reason it's 12 is because 12 squared is 144. So I'm going to say, Alex, how do you know that? How do I know that square root is 12? Well, there is a way to actually check it. You can use so-called scientific calculator. So I start typing in Google scientific, and right away I get a first choice here. So what I do is I use this calculator to do the demonstration. So we can put a square root of 144, and then the answer will be 12. So you can always extract the square root from the number using that nice little calculator. And I guess that's the nice thing to know. You have completely free device available online. If you don't have a calculator, you just type scientific calculator and get one right away. Well, not all numbers you can that nicely put in the scientific calculator, and that's why we are trying to do these problems in a section. So if I look at exercise number 41, that says negative square root from 25 over 49. Well, 25 is 5 squared, and 49 is 7 squared. So what I'm trying to do is show you the numerator will be 5 and denominator will be 7. But this minus is still going to be with us because this minus has nothing to do with the square root. So the whole thing will be negative. So the minus does not disappear. And you say, well, what happens with 43 here? When they say the square root of -4 is what? Not real? Well, it means you cannot square root negative number. If I try to do this anyways, if I try to square root number, what was it? Double check. -4. So if I put square root and -4 inside of it, the square root is not possible to extract from negative numbers. You see, why not? Isn't that 2 or the -2? Well, just check it out. If you take -2 squared, it's going to be the same as if you multiply a -2 with the same exact -2. So when I multiply those two numbers with each other, I'll get positive number 4. So please notice when I try to square root -4, I can't. I could get positive 4, but not negative. So the problem is negative sign inside the square root that stops us from extracting that square root. So whenever you try to square root the negative numbers, like -4 here, you can't. It's not gonna work. So you just need positive inside the square root. What's happening on the outside, nobody really cares, but inside you need to have positive. So let me try problem number 47 that says extract the square root from 25. When you say, oh, I know it's 35, right? Or you can say it's 5 squared. And then there is another square. It's a square of letter x. Okay, so it's 5 squared times x squared. So when I extract square root, I'll just get 5 without square and x without square. And that's what they have here for the answer, but they put also absolute values of x. Why would they do this? Well, it turns out that they want to make sure that the result is positive. That's why they do this. I'm not gonna really pick on that. That's kind of formal, but turns out when you square root any number, like here, when you square root 121, you got positive 11. You didn't get negative 11. So they want to make sure that the result is positive. That's why they put these absolute values. Again, it's good to realize, but I don't think we're going to use it much. But I think it's good that you see it for once, and then this will let you not to worry about these absolute values. I know some people, for some reason, don't like these bars and feel kind of uncomfortable. So similarly to square root, you can extract other roots, such as a cube root. In exercise number 55, they're talking about, let me write it nicer, 55. They extract a cube root from number 1. So when a cube root 1, then this has to be 1. And again, because 1 to the power of 3, which is 1 times another 1, will be equal to number 1. So when you multiply 3 times, or people say when you produce cube. So when you produce that cube, then you multiply 3 times the number with itself, and That's what cube root extraction stands for, 3 times. So if I try number 56, they say it's 8. I say, how do I possibly know that if I extract cube root of 512, I get 8? Well, it turns out that if you multiply 8 by another 8, in other words, if you look at 8 to the power of 3, this is going to be 512. But of course, you don't need to know it. You can just try to cube root. You can go back to this calculator and double check if number 8 times another 8 times another 8 will give you indeed 512, and it is. So 512, it is the result. I say, but how would I be able to cube root with this calculator? Well, look at this symbol here. That's called nth root. So you can put any root you like, just instead of square root, people automatically think of degree 2. So you could just use 3 here for the cube root, and then you enter 512 and get indeed numbers. So this is a nice calculator, and I think that in the future, if you be taking any classes related to math, you don't have to look for the calculator. You could just get one free, totally free online. I just put the link to it in the Zoom chat for everyone. So if you know how to use this calculator, I think it'd be very, very helpful. In fact, lots of classes, and if you especially take some classes related to online, that's called MDC Live or pure online. We'll also have online classes in our college. Then you can always see those schedules. Maybe I can actually show you how to find those if you be interested, because I know sometimes people don't know how to find a class. So you just need to open another page, as I say Google. I go MDC class schedule or class search. So you can just click on, you start typing, it comes out. So class search, so you choose first, search for the classes. Then what you can do is select the semester. Let's say you go in summer or say fall 23. So you select fall 23, and you don't need only open classes. Maybe you can just see what is going on in reality. So let's say you want to get some math class. The next class after this one will be Mac 1105 for most people. So if you decide to take it online, we have here online, MDC online, or you can select our West Campus. Either way, you can get the class. So once you selected the campus, then you can just click search, and you will get a whole bunch of classes. Oh, too many classes. So there are lots of classes then, so you need to be a little bit more specific. So if you select something a little bit more specific, so I just didn't know we had so many classes. So if I go fall again, so if I go subject Mac, so I guess you need to know the class a little bit better. So you select which class it is, course, location. So is exactly campus. I'm kind of surprised we don't have, maybe I'll just try our campus, West Campus. So, and then I click search, because if you go for location, it's kind of same thing. So I'll select search. And here you can see various classes in our location for the fall semester. So you can see there are some classes that meet at various times, which times work better for you. So if you like, let me clean this mess a little bit because it's on the way. I think it's probably time to do a schedule, right? I think the registration actually for the fall starts today, is it? So you can see what classes work for you, because I know that some students like to go to the counselor, and counselor gives them just random classes, but maybe instead of taking a class that goes Monday, Wednesday at night at 5 p.m., you would prefer to have Monday, Wednesday, Friday in the morning. So you can always see what class is better for you. And looks like we have plenty of classes. And right now, I think all of them have enough room. So that's for the fall semester. So I would recommend that you go with the fall semester as soon as possible, because classes, again, do get filled up very quickly. I'm just wondering what's going on with online. They didn't. Oh, return, or would you like to continue? Okay, just click OK. So you click OK because there are lots of online classes available. So you can see there are so many online classes available. They never give the time for those classes because they're online. So they don't even care what time it is. That's another alternative. So just for you to know that you could just go MDC class search, and that's something that will help you to get the schedule. And the same thing for the summer semester, which the registration for which is already going. So you can check and see if you want to take something in the summer. I already recommended you my class in the summer for Mac 1105 for the a little later start in the semester. So you can have a month and a half break and then get it the same way as I teach this one. It's called MDC Live. So anyways, let me go back to the textbook and see what else is here. So we extract various cube roots here, and notice that in such exercises number 57, I can extract the cube root from negative number. The reason is it's a cube root. So when you extract cube root from minus 27, it's equal to negative 3, simply because minus 3 raised to the power of 3 is indeed negative 27. Please notice that whenever I start working with negative numbers, I put them in the parentheses. I'll make sure that it looks kind of nice. You don't really have to, but as long as you understand that this is actually a negative number. So if you multiply minus 3 with minus 3, you get plus 9. But when you multiply it by another minus 3, it'd be indeed negative 27. So the message is square root you cannot extract from negatives, but cube root you can, because when you check, what you do is you multiply 3 negative numbers because it's a cube root, so you need third power, 3 times negative, and 3 times negative is negative. The problem with a square root was when you multiply negative by another negative, it becomes positive. But when you multiply 3 negatives, it's still going to be a negative. So like in problem 59, the minus still present, it still stays. And when I square root 64, sorry, cube root 64, it's going to be 3, because 4 times 4 times 4 is 64. And denominator, cube root of 27 is also 3. So I got result. So the message is one needs not to panic when encounters those roots. They're fine. They just utilize them or use calculator. So how about exercise 83 that deals with the force powers or force degree root here? So in exercise 83, we have a force root that we extract from 1/16, which I can write as 1/2 times 1/2, and so forth. I can have 2 to the 4th on the bottom, because 16 is nothing else but 2 to the 4th. Let me write this a little bigger. So 2 to the power of 4 instead of 16. And then it's also multiplied by x raised to the power of 4. One wonders why this is multiplied, because in the original exercise it is not. Well, no operation is always times. So it's multiply. So instead of x to the 4th, I get just x because we extract now force root. Notice that force root and force power, and they cancel. And the same with 2 to the 4th, so I just get, oh, you already need to go. Okay, you can go, that's fine. Maybe I'm not gonna give a quiz today, so it's okay. So you can just enjoy the rest of the day. We'll have a quiz on Wednesday, no worries. Today, I just want to introduce you with a little bit of radicals. So you start to feel better, I hope, about those. Maybe you already feel good, that's even better. So anyways, so when I extract the force root or cube root or square root, I need perfect force power. So force root, force power, cube root, third power. And that's the point of this section. So how about graphs of those? Well, it turns out that to get a graph of radical function, they spent a little bit of a time to produce a bunch of points and to connect them with the continuous curve. And it turns out that in this section, we deal with the square root like graph, which is a half of parabola. So the graph of a function square root of x looks somehow like that. So it starts at point 0, 0 at the intersection of axes, x and y, and then it continues all the way to the right. And they actually discussed this in the beginning of section. You can just scroll up and see this graphs they produced. They worked very hard, and I'm impressed on how they do this. They had a bunch of points they calculated in example 7. So first point was coordinate 0 for x and 0 for y. Then they calculated point 1 for x and 1 for y. Then they had another point, more points, and then they connected them and produced that graph. Well, which is not very surprising, right? That's a standard procedure in here. So they get the square root, and then they also utilize this to graph something like here on the picture, which is a square root of x plus 2. So notice the remarkable part of that graph is that it's kind of the same thing, but now it starts at point 2 and also goes upwards. Let's see, so is that the same thing? Well, the shape is the same, but the whole picture, since we added 2, is moved by 2 units upwards. So the graph is here. You see the graph is moved. And that's not a coincidence. Turns out that whenever you add some number, then it moves the graph. one way or the other. And I'd like to say a couple of words about this because I think it's very interesting. And that's actually a start of story of next class, which is called college algebra, that talks about graphing. So today I'd like to take a little look at the exercises 91 and so forth. And as I said, not give you a quiz, just let you go and think about this, because I'm giving you a little flavor of the college algebra class. So you're going to do lots of graphing in that class, like in exercise 91, I have to graph a square root extracted from x plus 4 function. And it turns out that what people do is move this graph by 4 units to the left and have it an exact same shape as we just had the square root here on the right side. We need to take that function and move it 4 units because it's x plus 4. And if one wonders why this is 4, because it's actually added, why did you move it to the left? Well, you can verify this by checking out what numbers actually don't work for my function. Remember, the square roots, we don't extract from negatives. Like if you try square root -1, it is not going to work. So people say that this x plus 4 needs only to be positive, which means that x needs to be greater than -4. So we indeed start at -4, and x can be anything greater than -4. So indeed, all x possibilities that are to the right, that are greater than -4, perfectly work. So we have indeed correct graph. Interesting, isn't it? So from -4 all the way to the right is what I just produced. So we have kind of supported the fact that we move it to the left, that graph, rather than to what common sense would tell us, well, you add it, you move it to the right. No, it goes to the left. See, that's something worse to think of. So let me do 92 and I'll let you go. I know it's something a little bit different. So how about if I decide what to do if they want me to graph exercise 92? Well, what I'm going to do is take a look at the part of this, such as a graph of square root extracted from x minus 2. It's not really minus in front because we have a 92, it's negative, right? But first of all, I'm going to graph that x minus 2 function. And the way I graph it is I start at 2 and go to the right. It's kind of similar to the previous, because in the previous I had x plus 4 inside the square root, and x plus 4 means that we have moved the graph by 4 units, but to the left, the opposite. So now we're subtracting 2. So instead of moving to the left, we go to the right. See, it works kind of opposite to common sense, right? It's not really the same, which is interesting. So anyways, so x minus 2 is inside the square root, and well, the graph is moved to the right. And one can say it is not really surprising because, again, similarly to what we had before, we can say that x minus 2 must be greater than 0. So x must be greater than 2, right? So indeed, it starts at 2 and goes to the right. No negatives. Well, that's not it, because you can see there's also minus in front. So what happens when you get a minus? I say, Alex, I see what happens here in the picture. They graphed this like that. Yes, they reflected their graph through x-axis. Turns out that whenever you have a minus in front, then you do reflection. Like say here, if you have a square root of x, then when you attach a minus to that square root, then you're going to get this graph mirrored through your x-axis. So that's another interesting observation that I just made. So if I try to graph the actual exercise 92 that says with a minus in front of that x minus 2 inside the square root, well, then the graph is going to start at point 2 and continue to the right, but be flipped. Whenever you have a minus, it's always like that. So as I said, I'll let you go today without a quiz. I think it's good enough of new information for today. So I'll let you think about this. And also I'll let you think about the schedule for fall semester, because I believe that today registration for fall starts, and I recommend you to look at the schedule that I have already considered just a few minutes ago. So check the schedule and think what classes you would like to select, because I had a student who told me that he went to counselor and counselor gave some classes and he was wondering why he needs to take my night class because he was a morning person. And I told that look at the schedule, just switch the class. It's so easy. You just need to log into your MDC student login and change the class, drop one and add the other. And this day, today, you can do it. You can select any class you like pretty much because all classes are open. If you wait until August, well, the most good classes will be closed. You say good classes. Well, the good times, that popular times that people want to take, and all you got maybe left with some like Friday night classes or something that nobody wants to take. So that's why advice is do it today because you have more choices. So I'll let you do this now. That's why I'm going to end it at this stage and start to think about the choices for the fall semester and also see what's for the summer, because sometimes there is a prerequisite course you need to take art 2, but maybe before you need to take art 1, right? The prerequisite. And that's why you want to sign for that class maybe in the summer and then take the next class in the fall. And again, you can always check it out online because it may not be available in our campus because there are some rare classes that they don't teach in the summer on our campus. But if you check MDC online, you can probably find them. So that's why it's good to have all options opened. And since we already went through this class pretty much, I think we're pretty much done. Another week and then we're gonna start discussing the final. So it's another 2 weeks of class basically. But today's day and then next week we're gonna discuss the final, and then week after next we will have final. So there's really pretty much no time left. So it's a good idea to start creating schedules for next semesters. So anyways, let me end at this stage. So thank you so much for being